Welcome to ProdataKey's Access Control 101 live courses. We're really excited to bring these to you, certainly during these uncertain times. It's important for us to really deliver value, not just to our dealers, but to anybody that's interested in really understanding low voltage cells, as well as the technical side of the experience. So we really want to deliver value to you today in helping you understand power, wiring, amperage, voltage, and the whole powering schematic behind access control in general. My name is Jeff Perry. I'm the president and co-founder, the COO of ProdataKey, and I'm excited to be presenting to you today. I've got 15 years of industry sales and technical installation experience, and can really deliver to you some important tips for consistency and understanding power that I think will be really valuable to you. I'm an award-winning business strategist and trainer. I've done trainings all over the country and really excited to present to you today. So the first thing that I want to go over is just a couple of housekeeping items. Number one, this is a live class. So as I'm talking, if I make mistakes, it's live. So we're not going to be editing it. But also, we want to make sure that it's somewhat interactive. I'm going to be showing a lot of product. Though you have the opportunity to ask questions, and questions are greatly encouraged, those will be asked in the chat. So just go into the chat here on YouTube Live, chat your questions, and they'll be sent to me, and we'll answer each of one of those questions during the live Q&A. So as I'm going through this, I'm just going to go through this as a straight training, and then we'll answer those questions during the live Q&A at the end. And again, this has really helped to help you design and help you improve your service and installation experience while out in the field and while working with access control and low voltage equipment. So this doesn't just pertain to access control, but it can also pertain to other facets of your organization. So let's look at power implementation and what power implementation means. These are each of the items that we're going to be going over. Number one is linear versus switching power supplies. Number two is working with clean power, 12 to 24 volt DC power supplies, line loss and wire gauge, amperage calculations, battery calculations, fail-safe versus fail-secure and how that interacts with power. PoE, or power over Ethernet, and being watt smart, understanding the watts of a power power that's coming out of a PoE switch, and then ultimately being consistent. And that's what I'll talk about first today. Is just this opportunity of consistency. One of the things that I've seen time and time again, and I continue to see in our support department as I talk to them about support instances and them helping techs out in the field, is some lack of consistency and other areas where individuals are very, very consistent. And what I would say is that in every instance where you can be as consistent as possible, you're going to save an enormous amount of time and an enormous amount of money by your consistency. That comes to power, wire, in some cases product, but ultimately with power and wiring, when I go out to a project or a job and I pop up a ceiling tile, and if I see something different than what I experienced on a previous job, that now all of a sudden starts to cost me time and money. And we all know that there's some power behind efficiency. Certainly in these times, when we can be more efficient, there's some benefit there. So I'll talk a little bit more about wire in the future, but as I talk about power, I want to just touch on wire just a little bit. You know, there's many different types of wire that you see out in the industry, and I've got a couple of boxes of wire that I'll show you throughout this presentation. But that's one of the biggest shortfalls that I see in installations, is just the type of wire that's being used. And again, if you want to give your customers the experience that you know, you're an industry leader and you're really being consistent in your projects, then be consistent with the way that you do your installations, the way that you do your power. And again, sometimes that even rolls to the types of products that you're using. So when I talk about wire, I've seen many instances where Cat 5 or Cat 6 is used, or just individual strand wire is used, where you're pulling an 18.2 to something, a 22.4 or 22.6 to something else. And then I see another level where there's real consistency in pulling access control wire. Many people refer to it as banana cable. It's the yellow cable that's got all of your wire for your locking hardware, your request to exit, your reader, etc. And the reason that I bring that up in a power presentation is because it has everything to do with power. Number one, you're consistent in the type of wire that you're pulling. But number two, typically an access control loom or a banana cable has all of the wire that you need and the proper gauges that are needed to utilize the correct current and amperage for particular products. So I wanted to make sure that we talked a little bit about wire and being consistent. Also, make sure that you're consistent in how you're powering products. So as we go through this presentation and we look at different power options, again, make sure consistency is king, and you'll win every single time. Also, when you have another tech that comes to a project that you may have installed, or vice versa, they know what to expect when you've went in and installed that product in a specific way. So let's start out by talking about linear versus switching power supplies. There are two very distinct pieces differences between a linear power supply and a switching power supply. The first one is a linear power supply is very heavy. You can use it to break windows. You can use it for many other things, but it's very inefficient. So if you look at its efficiency rating, they're typically running between 30 and 40% efficiency. It's a much more simple design, but one of the benefits of a linear power supply is a very low EMI noise. We're going to talk about noise in power in just a little bit, and I've got quite a few slides that will illustrate the different types of noise in power. But it's typically a higher cost in some cases than a switching power supply because of the amount of material that's in there. So what I want to do is give you a little close-up of a linear device and a switching power supply, so you can see the differences between these two products here. This is more of a transformer or a coil, but it's typically included in a linear style power supply like you saw on the slide there previously. But again, very, very heavy. It's probably something that my son is using to work out during the quarantine time and not being at school. It's an extremely heavy device, but like I said, it has a lot of material, and typically it's copper, so it becomes much more expensive. But like I said before, it typically has a much lower EMI noise to it. So if you've got products that you're powering that are very sensitive to EMI noise, then using a linear power supply can typically help with that. It's not very often that you're going to run into those scenarios, but it's something definitely to look at as you're powering product. Now let's look at a switching power supply. This is a switching power supply by Electronics. You're going to see it has a lot of components on here, but most of these components are for additional functionality for the power supply. You can bring line voltage directly into this, so it's handling that as a transformer as well as a switching power supply as well. Let me show you one additional power supply to this. This is a switching power supply as well. It has much less functionality to it as a switching power supply, but again, you can bring line voltage into this. A portion of this power supply is used as the transformer to transform that high voltage power into low voltage. So this comes in at anywhere from 90 to 240 volts AC, transforms that to a DC voltage, and then drops it down to 12 volts DC at 2 amps. So that's really unique when you're talking about a switching power supply, and you can see that it's a much smaller footprint as well. There's another another thing that I want to note here, when you look at this Ultronics version of that power supply, again, is it's got its transformer on here. You're typically bringing in 120 volts AC, and then that's dropping down to 10 amps at 12 volts DC. And this can be a 12 or 24 volt power supply. So if we come back to the slide, what I can show you is that, again, a switching power supply is typically smaller. It is a more complex design because a lot of times it has more functionality to it. It can do more, but its efficiency is much higher. You're typically doubling, if not greater, your efficiency of the power supply. In other words, a linear power supply, you're burning that power off. So when you bring 120 volts in, you're bringing it down to 12 volts DC. What you're doing is you're creating heat, and it's burning all of that power off, and that's what's bringing that power down to 12 volts DC. It's very similar to like simmering a sauce on your stove, right? You heat that liquid up, and as you heat it up, it starts to evaporate the liquid from it and starts to thicken it up. And that's similar to what a linear power supply does, is essentially heating up, burning off that power, and bringing you down to the voltage that you need. And that's why you're going to see that a switching power supply is significantly more efficient, because what it's doing is it's switching at a specific hertz. So it switches on and off at such a high rate or a high hertz that it's, instead of burning that voltage off, it's just bringing that voltage down by switching on and off at a specific rate to bring it down to, in this case, 12 volts DC at 10 amps, but it could be at any particular amperage. What's unique about that is that you bring the cost down a little bit because there's less material, but you do increase your EMI noise. With ProdataKey, we've got a couple of wireless components, and what we found is when you couple a switching power supply with wireless products, you're typically bringing some of that EMI noise in, and that can affect some of your wireless signal. So just keep that in mind as you're powering products. If you're utilizing wireless pretty heavily in a specific project, and you're powering those with a switching power supply, if it's a low-cost switching power supply, you could have really high EMI noise, and you may need to filter some of that. Now, there's two types of EMI that you could run into. Some of that is linear. It's coming right off of the power supply itself. So if you're powering a product that's very sensitive to EMI noise, you're going to run into issues with that product or decrease its functionality. It's not really common, but it's certainly something to address as we talk about power and how we're powering products. There's also ambient EMI noise. So if you've got a wireless product, let's say you've got some wireless devices providing Wi-Fi for a building, or in our case, if we're using a wireless single door controller, and you mount that really close to a switching power supply that's putting off X number of hertz, and you're getting this transient EMI noise, then you can really decrease the amount of transmission of a wireless product. So it's certainly something to address as you're looking at coupling power, whether that's linear or switching power supplies with wireless products, and understanding the noise or that EMI noise that you're going to have. We're seeing linear power supplies kind of being phased out, and they have been for some years now. So when you go to distribution or you're purchasing power supplies, a majority of the power supplies that you're purchasing are switching power supplies. And switching power supplies have become much better at decreasing that EMI noise that you see. So it's not as much of a problem as it has been in the past, but if you're using older or very low cost switching power supplies, you could run into some EMI noise issues. So keep that in mind. Those are two of the greatest differences, again, between a linear and switching power supply. So as we go through this, that's really important to note and understand. The next thing that I want to show you is working with clean power. Again, we talked about EMI noise, which can play an issue, but there are other things that can play into the problems of dirty power as well. And dirty power can cause a lot of problems when you're talking about powering electronic components. certainly even access control, and decrease the amount of life that they have. For instance, if you look at an OSA Abloy lock, you can increase the warranty on one of their lock sets if you utilize one of their filters or a little pack that runs in line with power to help not just decrease the dirty power itself, but it also helps when you're using continuous duty of a strike, and we're going to talk about that. So making sure that you've got good, clean power is something that's extremely important. Typically, the causes of dirty power are going to be, rapid load changes, whether that's underload or overloading, increasing your voltage, and again, decreasing your voltage of products. And that can, like many understand, really affect computer equipment, other electronic equipment as well. And then also ground faults. So if a building that you might be working in has issues with ground faults, you can run into issues there. There are ways to really clean this power, and a couple of those ways to help prevent dirty power are installing a line conditioner or utilizing a UPS. And really, when you look at a line conditioner or a UPS, I know Dytech, if you're unfamiliar with line conditioners, you can go to Dytech and they've got fantastic products at conditioning line. Minuteman provides fantastic UPSs. They're somebody that you can look to at utilizing a UPS. What I want to do is I want to bring a couple of these devices in. And actually, the UPS that we have is something that many of you guys have seen. It's just something that I pulled from here in the office. And this is a UPS. What's unique about this is that it has surge protection built into it. So you get a line conditioner built in to almost any UPS. And that's really the difference between a UPS and a line conditioner, is that a UPS has a battery pack built into it, where a line conditioner has no battery backup capabilities or properties. It's more or less just conditioning that power and cleaning that power up for you. So those are the two things to consider when you're looking at power. If you already have a battery backup in place or a main UPS along with maybe a generator for battery backup, there's not as much need in utilizing a UPS on your products. So if you go into a network closet, you're mounting your panel, and you're plugging that all into an existing UPS that they have, and they've got enough amperage and power to facilitate powering your hardware, and they've got a generator connecting to that, typically their UPS is going to take that load as soon as you get a drop in power, a brownout or power outage, and it's going to continue to power your equipment. And then the generator is going to pick up and switch over. So really that UPS is not only taking the load and continuing to power your equipment, but it's also cleaning that power as you run into power dips or other issues that you're going to run into during those brownouts before a power outage, or merely if you just have brownouts, period. And then when that generator spools up and it switches over to generator, it's going to make that switch and again keep that power fairly clean for you. So in those types of scenarios, you're not really dealing with with your own UPS. So there might be some scenarios where you don't need battery backup, and if you are in a situation where you don't need battery backup, then installing a line conditioner might be enough to clean up your power. So just make sure again that you're looking at all of those facets of your installation as you're getting into this, and understand the difference between a line conditioner without battery backup properties, if you don't need battery backup, and also utilizing a UPS that will do some line conditioning for you as well. And there might be scenarios where you may need to do both. There was an instance where I was installing a very expensive camera at a military base, and they flew jets out of this base. And one of the biggest issues that they had is every time the jet would turn to make its or to take off, you would run into an issue where the propulsion from that jet would create enough static power to burn up that camera. So there were issues with grounding, but there were also issues with line conditioning and battery backup. So using a combination of line conditioning and battery backup, we were able to solve a lot of those problems with that static electricity. So again, you're going to run into every kind of scenario that you can think of. So it's important to understand the differences between line conditioning and UPS and having clean power. So what I want to show you now is a couple of the issues that you can run into, and we're just going to really glide through a couple of these scenarios very quickly, okay? So this first one here is a power disturbance called normal mode noise. Typically the definition of a normal mode noise is a low level signals. It's superimposed on the power sine wave. So if you look at the sine wave, you're going to see a much lower signal. The causes to this are typically computers, switching power supplies, power line modulation equipment. So again, a lot of the typical equipment that you're utilizing in your day-to-day environment can cause some of this fluctuation in noise. So some of the possible symptoms are processing errors. So if you're utilizing access control in this case, you could run into issues where you're getting errant card reads or inconsistent data if you're running into normal mode noise issues. Also, you could run into terminal or printer errors. So if you've got a terminal that you're using or a printer and you're seeing lines or issues in that, you could run into problems. We're not utilizing terminal printers as much, printers like they did in the past, so it's probably not something that you're going to run into. The next one is what we call normal mode impulsing or ringing transients. And this is a narrow or a fast rise of voltage variation, and that's typically followed by a dampened oscillation or a decaying or this breakdown of power that brings down less than one cycle. So if you were to look at a sine wave, you would see one cycle of that sine wave is one of those humps. So it's typically happening within one of those sine waves, and the cause of that is switching loads on or off. And we all know back in the day, when somebody would come in and flip a switch or unplug a computer without powering it down, you'd run into issues there. And that's usually what this is showing. So switching loads on and off, this could be a brownout, computers or utility switching, lighting, etc. So again, very similar, you're going to run into some inconsistent data, some errors, as well as some I/O hardware damage. Many of you might be aware of, in the past when you'd unplug a computer, it's possible that you could damage the hardware of that computer. So this is something, again, that's important to look at. Common mode disturbances, again, we're not going to spend a ton of time. This is impulses and EMI, RF noise, again, very similar to what we were talking about before. Radios, computer, those types of things are the cause of that. And again, incorrect data, processing errors. So you can see that a lot of the symptoms are very similar as you go through each one of these. Power sags. I want to touch on this a little bit more. One of the biggest issues that I see in not just access control, but many facets of power are underpowering or having power sags. So when you're looking at power disturbances, a power sag is where you really drop your voltage down and you're underpowering your equipment. Now, a power sag wouldn't just happen from an issue with the power, who's bringing power into your building, but it can also happen for many other reasons. And one of those could be by utilizing, the incorrect transformer. So when you purchase a transformer and you're powering another power supply or a product with a very low-grade transformer, a lot of times those transformers are brought in at about 12 to 13 volts, so they're really brought in at spec of the product that you're going to be powering. So when you plug that in, if it's a low-cost transformer and you're running at maybe 12.5 volts, what happens is eventually those power supplies start to burn in, and then they'll start to sag, and you'll be powering that equipment with maybe 11.5, 11 volts after several years of use. And depending on the quality of the transformer, you could really depreciate the time that your electronic hardware is going to last. So again, it's not just based on your utility coming into the building, where you could have a power sag for a moment, but you can also run into power sags or underpowering your equipment, which is the most catastrophic thing that you can do for hardware. Honestly, it's better to overpower your hardware slightly than to underpower your hardware slightly or significantly. So obviously, if you overpower your hardware significantly, you're going to see smoke and blow it up. If you underpower your hardware significantly, your hardware could, in essence, continue to function, but you're going to put a lot of wear on your hardware. And so that's what power sags, based on your utility coming into your building, can do, is really create a power sag, and your hardware may continue to function. But what will happen is eventually your hardware will take some pretty big hits because of that. You'll start to see system crashes and hardware damage because of power sags. And so again, I can't emphasize enough, make sure that you're purchasing, when you're powering your hardware, that you're purchasing substantial hardware. If you look at this power supply here, and I'll get an up-close look of a couple of these power supplies so you can look at them. This power supply on this side really starts out at 14 volts. Okay, now it's rated at 12 volts. So if you look at the rating on it, it's 12 volts DC at 2 amps. Okay, but what happens is when this starts to burn in, you're going to see it kind of sag down to about 13, maybe 13 and a half volts, somewhere in there. But it's not going to drop below your 12 volt range. So if you're powering 12 volt hardware, you shouldn't run into an issue with this type of power supply where you're underpowering your hardware. Now, where you will run into issues is with a lower cost transformer. If you're utilizing a lower cost transformer, this one's rated at 13, just under 13 volts. And what will happen is eventually that's going to sag and burn in, where you're going to be running that at less voltage than what your hardware is powering. So again, keep that in mind as you're powering hardware, that you want to make sure that you're providing transformers that are significant enough and are going to give you the longevity that you need out of your project. And that certainly applies to power supplies as well. Regardless of being linear or switching power supplies, make sure that we're not purchasing the least or the most cost-effective solution out there, or the least expensive. Make sure that you're purchasing the one that's going to fit the project the best when you're talking about power output and amperage output, to make sure that you are going to be able to run this equipment into the future. Now, another thing to identify is you can make up for a little bit of that sag with amperage. So if you've got a 12 volt DC transformer that's running at 14 volts and you're running at 2 amps, but you're only drawing an amp worth of power, and we'll talk a little bit more about this later, but you're drawing an amp worth of power, if all of a sudden that starts to sag, it will utilize some of that amperage to bring that voltage back up and continue to power your hardware accurately. And again, there are a lot of different scenarios to that, but amperage can make up a little bit of the difference in some of the voltage loss that you could run into. Okay, so now let's look at harmonics. Again, this is just quick voltage variation. So you've got voltage dropping and spiking pretty substantially. Switching nearby loads on and off is typically a cause of it. So again, if you've got power coming into your building through your utility, and that utility is very inconsistent on and off, you could run into issues there where you've got this harmonics and this again, this disturbance is typically less than 1 cycle, but it can last several cycles if it's coming on and off. And again, causing a lot of the same issues, data corruption, power processing errors can really damage your hardware, cause lockups of panels and those types of things. Over voltages. Now, like I said before, is a slight over voltage. So a product that utilizes 12 volts DC and you're powering it at 13 and a half or 14 volts, most of the time, again, you're looking at a piece of hardware, and that piece of hardware is saying that it can run up to 16 volts. So it may say, this hardware can run between 12 and 16 volts. And so if you're using a 14 volt output power supply that typically is rated at 12 volts, that's not an issue at all, because again, you're within that voltage range. But if you start getting above 16 volts and running that thing at 18 or 19 or 20 volts, you could really start to cause some issues. And again, you're typically going to burn something up at that point because it just doesn't have the capability of being overvolted. But again, be sure that you understand that difference in overvolting slightly up to its maximum capacity, or overvolting above and beyond that. I would always recommend overpowering your hardware slightly, not all the way up to its maximum, but again, somewhere in there so that you can be powering your hardware. And most power supplies and most transformers automatically take care of that, so there's very little that you have to do. But if you look at the schematics behind a transformer or power supply, it will tell you that it's putting out 13.5 or 14 volts. And some switching power supplies also have a potentiometer on there allowing you to turn that voltage up slightly or down slightly based on the voltage draw and the amperage draw that you have. And so that can play into line loss. We'll talk about line loss a little bit more here shortly. But again, make sure that you're not always setting your power supplies right at 12 volts DC if your hardware is sitting at 12 volts, because as that power supply starts to decay a little bit, it could settle down in that 11.5 volt range. Also, you have to make sure that you're accounting for what we call spikes. So if you've got a strike in essence that's locking up or unlocking, depending on if it's fail-safe or fail-secure, if that strike unlocks and it's taking power to unlock it, you're going to have a very quick voltage spike, and then that spike will settle back down. And amperage plays into that as well. But again, that plays into making sure that you overpower the hardware slightly, but always make sure that you're looking at the range of voltage that hardware can handle, so that you're not substantially overpowering it above its peak, or even flirting with that edge. Bring it down below that just a little bit. But again, like I said, as most power supplies and transformers will take care of that. The transformer that we sell is, again, setting at 14.5 volts. But most equipment is okay that's ran at 12 volts at running at 14.5 volts. So overvoltage is okay. Substantial overvoltage, you're just going to damage your hardware. And typically, it's a very quick damage. You're going to see it if the product smokes immediately. And then obviously you've got power outages. We all know what power outages do. The power outage just drops out. This is typically described as a duration of greater than a half a cycle. So before we talked about these peaks and valleys, and it's lasting for one cycle, so it's typically a quick on-off. An outage is typically greater than a half a cycle, so there's no voltage coming into it. It could be a ground fault, equipment failure. Those are a lot of the causes. When the power goes out at your home, typically it's a transformer that's out on a power supply or in the ground that blows up and causes issues, right? If it's not a power line issue or something like that. So again, the power coming into your home, it is utilizing transformers as well to help deliver that power efficiently. And so you can cause, problems can be caused there, as many of us have seen. So obviously a system could crash, you can cause hardware damage. And so that's the benefit of utilizing a UPS and line conditioners. Now obviously a line conditioner isn't going to help you in a power outage situation, okay? So if your main concern is power outages, which should be all of ours when we're looking at access control certainly, but even other critical components within low voltage, you want to make sure that you're incorporating a UPS and making sure that when you're looking at the UPS, determining how well it conditions that voltage. And if it doesn't do line conditioning very well, make sure you add a line conditioner if needed. Most of them, certainly if they're built for this type of use or commercial use, have line conditioners built into them, so you won't have to worry about that. But again, a UPS will help in an outage situation, but line conditioner will not, because it doesn't have those same capabilities. So let's look at the difference in 12 and 24 volt DC power supplies. This is something that comes up all the time when you're talking about power, is how do I power my equipment? You're going to find that many strikes and other types of hardware can be powered at 12 or 24 volts. So what I want to do now is just go through a 12 volt DC power supply and show you on this bullet list what you're going to find is most advantageous of a 12-volt DC power supply. It typically has more resistance. So as you're powering a piece of hardware, again, you're powering it with less voltage, but you're powering it with greater amperage. So when I compare this to a motor in a car, it's typically the amount of horsepower that you have. The voltage, I typically will equal that or put that equivalent to the gas that you have in the vehicle. And then your amperage is how much horsepower that you have in that motor you're generating. So again, the greater the horsepower or the greater the amperage, the more resistance that you're going to have. So when you're utilizing a 12-volt DC power supply, you're going to have greater resistance because typically you're relying more on amperage than you are power or voltage. The second one here is you're going to use a larger gauge wire. And you're typically using a larger gauge wire because of what we just talked about, is you're drawing more amperage. So if you use a really small gauge wire, and that's why in the very beginning I talked about consistency and utilizing the right gauge wire, is because if you utilize a Cat 5 or Cat 6 cable and you split that out and you're powering some hardware, that's typically, 22, 26 gauge wire running to a piece of hardware and it's single stranded. So now all of a sudden that wire is going to get really warm, or you're going to cause a short in it or melt that wire because you're pulling a lot more amperage. So you've got to be very cautious and make sure you're using the right gauge wire. And what I want to show you now in a close-up is a wire gauge that's provided by ASSA ABLOY. This is one of the greatest tools that I've seen, and I know it's not super easy to see, but I'll go through a little bit of this here shortly and show you how you can determine the type of gauge wire that you should use when you're looking at the different types of power supplies and running at 12 or 24 volts. So we'll come back to this in just a minute after we finish going through some of these bullet points. So the next thing on the bullet point here is you're typically running 12-volt DC shorter distances. So if I'm utilizing edge devices, and what I mean by edge devices and access control is an access control board that's right at the door, and I'm powering all of my hardware right at the door, running 12 volts DC is typically not an issue and drastically recommended because you're running short distances. You can really keep your amperage and your voltage a lot higher. You're not running into line loss because you're running line substantial distances. So 12 volts DC on edge devices is highly recommended. Again, you're typically creating more heat because the gauge of your wire is greater, but you only need one battery. So when you're looking at battery backup with 12 volt DC, most of the batteries that you have, and we're going to really do a deeper dive into batteries, but if I bring a 5 amp hour battery here, this is running 12 volts DC at 5 amp hour. So in other words, if I'm drawing 5 amps, I'm going to get 1 hour of battery backup here. But because it's running at 12 volts DC, a switching power supply and a linear power supply both have battery leads coming off of it to do your battery charging. When you run into a power loss, then it will typically pick battery back up and provide battery backup to your product. But because most batteries out there are running at 12 volts DC, you only need one battery in those instances because it's running directly into your power supply. And when we talk about 24 volt DC, I'll talk about the difference in running two batteries versus a single battery. Okay, so let's come back to the list here and look. The other thing is better edge application like we talked about. And last but not least is better for low draw devices. So if you've got devices that you're powering, even though you might be doing a longer wire run with a proper gauge wire, you can power those devices much easier with a 12 volt DC power supply because you're not having to worry about some of the semantics of a 24 volt DC power supply if you're running into battery backup. If you're running battery backup, now you're needing additional cost when you're talking about batteries and maintenance in that way. Now, many individuals that have been in the industry for a long time clout 24 volt. And if you go into a lot of applications that have been installed for several years, 24 volts is very, very apparent in a lot of installation applications. We're seeing that less and less these days. And I attribute that really to more and more edge devices are being installed. So again, when I install an edge device, I'm running less wire. I don't have to run as high gauge wire, so my cost starts to drop. I'm only installing one battery. So now my cost for that installation drastically decreases. My maintenance on that drastically decreases. I'm not having to worry about the calculations of wire gauge because it's typically right at the door in that instance. So keep that in mind as you're looking at 12 and 24 volt power supplies. Let's look at 24 volt, and I've already talked a little bit about some of this. Again, you're going to have less resistance on a 24 volt power supply because typically you're powering a device with 24 volts and you're cutting that amperage in half. So if you're looking at horsepower in a vehicle, you're decreasing the horsepower of that power supply, you're generating less heat because you're pulling less amperage to those devices. So if I'm looking at a strike or an access control panel or whatever it may be, I'm going to look at the amperage requirements that it takes. If the equipment that I'm running, most of them that can run 12 or 24 volts, will give you that calculation based on the amperage and voltage. So what I want to do now, just quickly, is show you a couple of data sheets here up close where you can look at these power scenarios. Okay, so we've got a strike as well as another type of lock. So if we look at the strike, you can see on this side that it's giving all of the different types of voltage. And I apologize, I should have provided this as an image, but you can see it well enough here. You can see that these first ones here are 12 volt DC, and you can also see at 16 volt AC and 24 volt AC. And you can see how that amperage drops based on the amount of voltage. So again, as my voltage increases, my amperage is going to decrease going to that hardware, allowing me to run smaller wire. So maybe you come into an application where somebody already has wire in place. The wire is much smaller gauge and wire that I wouldn't use for a 12 volt DC application. Then you could consider running a 24 volt DC power supply, decreasing the amperage, therefore decreasing the size of the wire that you need to that particular product. So again, a lot of products out there on the market nowadays are 12 and 24 volt DC. They're field selectable, or you can just power them with either one and they select automatically. So make sure you're looking at that as you purchase product. And we're going to refer back to this when we start looking at batteries a little bit closer. But just make sure that as you're looking at the different types of power supplies, consider the hardware that you're powering and the type of wire that you're running to those, because again, that all plays into the amount of heat that you're going to generate or the amount of drag that you're going to have because of the amperage. Okay, so again, coming back to the list, typically a smaller gauge wire, you can run longer distances, you're creating less heat. So you can see that these are drastically, completely opposite from a 12 volt DC power supply. But the flip side is you typically need 2 batteries. And I'm going to show you an illustration of running 12 volt DC versus 24 volt DC, so we won't touch on that here. Just know that if you're running 12 volt DC, you can get away with 1 battery, but you can utilize multiple batteries if you need to increase the amount of amp hours that you're drawing. So in other words, if on a 12 volt DC power supply, I run 2 5 amp batteries, I can get a total of 10 amp hours out of that battery at 12 volts. If I'm running it at 24 volt DC and I'm running 2 5 amp hour batteries, I'm only going to get 5 amps or 5 amp hour out of that particular battery at 24 volts DC. Because I'm running 2 batteries and those 2 batteries connected together, you're going to split your amperage on those, okay? So the next, and again, we're going to get into that, so I won't go too crazy on that right now. Next is better in-home runs. So if I'm home running my power back to a centralized location. I'm not utilizing edge devices. That's something really to consider as you're looking at this. Also, better for higher draw devices, and they need half the load, which we illustrated before and we've already talked about. So those are the main differences between a 12 and 24 volt DC power supply. And there was, I've installed thousands of doors myself. And as I would go out to different projects, in the early 2000s, I would go out to doors and I would see some strikes rated at 12 volt DC, some rated at 24 volt DC. And for the most case, they were not field selectable then. So you would go in and do a system change out all this hardware, and then come to find out that a strike isn't working because it's 24 volt DC rated strike. You're running it at a 12 volt DC power supply, and it's typically not going to function at all. In one particular case that I remember, there was one door that wouldn't work. We couldn't figure out what was going on. Pulled the strike out, looked at the requirements on the strike. It's 24 volt DC. Luckily, it was a Von Duprin strike, so we unscrewed the solenoid, put a new solenoid on it that was rated for 24 volt DC versus, 12 volt DC versus 24. Wired it back up, and boom, the strike started to work immediately. So this can end up costing you money in the long run if you go to a project and you're doing a system takeover and you don't calculate for strikes that are rated at 12 or 24 volt DC, certainly those that might be substantially older and might not be field selectable. Some of those old ones, again, like I had addressed earlier, the Von Duprin strike, you can still switch them by switching out some hardware. Like this one, you switched out the solenoid and it worked great. But for the most part, you may run into issues. So as you or the sales team or whoever it might be that's doing the system or the walkthrough of the building, we want to make sure that as they go through that they're looking at those strikes, determining whether they're field selectable, finding out the power supplies that are already in place, and determining how you can power that equipment and the equipment that you're going to be adding to that as well. Okay? So now let's look at the different gauges of wire. I've already talked, we're going to have a session on wire and wiring, but I really wanted to illustrate the different gauges of wire because it plays such a substantial piece in powering equipment. If you power, if you do a 1,000-foot run or a 500-foot run and you're using 22 gauge wire and you're using a 12 volt DC power supply, you're going to end up at the end with, maybe 9, 10 volts. And your amperage can make up for a little bit of that, and it may make up a portion of that. But in the end, you're going to be underpowering your hardware. And a lot of times we don't look at that. So what happens is I get into a project, I decide, well, I've got some 22 gauge wire on my truck, so I'm just going to take that 22 gauge wire. I'm going to run at 500 feet. I run at 500 feet. I don't test the wire at the end and realize that I've got line loss or this attenuation in the line. And after a while, all of a sudden my hardware, because of being underpowered, I'm running into problems because I've underpowered it for a substantial amount of time. Now again, it might be enough power to keep your hardware running, but as that strike functions and as a mag lock turns on and off, those voltage spikes and losses could really cause some problems, and eventually you're going to end up replacing that panel and or the hardware that's at the door. So when you're looking at gauge of wire in the industry, you're typically looking at anything between 22 gauge and typically 12, 16 gauge, somewhere in there. You can go much higher, but it's not very common to do so. If you're utilizing, again, access control wire that's got a banana cable, most of the wires in there have the correct gauge of wire. But just know that if you're running a substantial distance, make sure that you're looking at the gauge of wire in the banana cable and make sure that your gauge is going to be correct. So when we look at this this gauge calculator that ASSA ABLOY has, it's a fantastic calculator for determining what gauge of wire do I need to run at what distance at which voltage. So if I look at the back here, and you can't really see this, but just take my word for it, you can move this calculator up and down. So I'm starting here at 1 amp at 24 volts DC. It's telling me if I run 100 feet, I can utilize 22 gauge wire. If I'm running 800 feet, I need to use a minimum of 14 gauge wire, which you see on the slide. When we come back to the slide, you're going to see the difference in a 22 gauge and a 14 gauge wire, and the thickness of that wire. Now, if I move that to 12 volts DC, and I'm running at 100 feet, I can run 20 gauge wire. So I need to increase my gauge of wire by 2 gauge, and if I run up to 600 feet, I would need to be at a minimum of 14 gauge wire, just like we illustrated before. So the 600 feet, but the 800 foot does actually change to 12 gauge wire versus 14 gauge wire. Again, if you don't utilize the correct wire, you're going to be heating up that wire, creating a substantial amount of line loss as well. It actually works very similar to a linear power supply, right? So this linear power supply is just a bunch of copper wrapped around a coil, and it's burning that power off. So if you're running a long way with a under gauge wire, all you're doing is burning that off and causing issues and substantially more line loss at the end. So make sure that you reach out to ASA Abloy, get one of these calculators. There's hundreds, if not thousands, of calculators online that you can use as well. But this is nice just to have in the back pocket or front pocket, and be able to do those calculations. On the back, when we get to the battery section, like I've addressed before, this also has battery calculations on as well, and we'll tell you how many amp hours you're going to get out of a battery depending on how much power you're drawing, and how much time you want. Okay, so if we come back to the slide, again, look very closely at the different gauges. 22 gauge versus a 10 gauge wire. Even your 12 and 14, 16 gauge wire are substantially greater. So the greater the number, the smaller the wire. The smaller the wire, the smaller the number, the greater size of wire. So I remember installing sound systems in cars back when I was in high school and just after high school. And as we would do that, obviously you'd run a very high gauge wire to create great power for your amp that's running in there. And this runs the same way, making sure that you're providing good, clean power to the products that you're running. So again, it attributes to the amount of line loss. And you can also go to Ultronics. They've got a fantastic tool. If you go to ultronics.com/public/calculators, they've got a calculator on their website as well. So we'll talk more about gauge wire and wiring in the future, but just be sure to understand that this plays a big piece into it. Okay, here's another line loss sheet. We won't look at this very substantially, but I want to make sure and put this up so that you could see it. And next, amperage calculation. So I didn't realize I actually do have an image of this, but if you're looking at electronic strike, okay, this is a 1500, 1600E Eco Strike, you're going to look at the voltage that this is powered with. So it shows that this can run anywhere from 10 to 30 volts, but let's look just, for instance, at the 12 and 24. That's most common for access control. So if you look at 12 volt DC, you can run the strike at 0.009 amps. But what's most important is your inrush current. What your inrush is, and let me just pull it over a couple of strikes here so you can see them on the table. You've got a couple of different types of strikes, okay? This one here is a mortise strike that's typically cut right into the door. And then you've got a standard strike that's cut into the mullion, and then what's called a rim strike that might be on the rim of a crash door. And we get into locking hardware in another segment in a couple of weeks. But what's unique about each one of these is they have two modes of power. One of them is inrush, and the second is going to be your holding or continuous duty. Okay? So when you're looking at continuous duty for a strike, continuous duty is how long that strike can stay, or that strike as it's staying open, how much amperage that it's drawing. But there are some strikes or locking hardware that are not rated for continuous duty. And again, we'll talk more about that in the locking side of things. But you got to make sure that you're utilizing the right type of locking hardware that can utilize continuous duty if you're going to have an auto open. But this plays into your power, because again, you're going to have the inrush of power as it initially unlocks. So this is almost a half an amp. and then it's going to settle back down to 0.009 amps of power that it's pulling on continuous duty. Now, if you're running this at 24 volt DC, you can see that it practically cuts that amperage in half. So again, you can do a longer line run, have less line loss, but it's typically, in this particular scenario, you're 0.220 amps at your inrush and 0.05 amps at your continuous duty. Now make sure that you keep this in your mind, okay? Take a screenshot of this or keep it in your mind as we talk about batteries next, because this plays everything into battery backup and how you're calculating your battery backup, okay? So let's move to the next slide here, talking about batteries. This is the last segment before we get into the Q&A. Batteries are so important. You know, Yuasa batteries are fantastic. Some of the highest rated batteries out there. If you utilize a Yuasa battery versus some of the other batteries that are out there in the market, I can tell you from personal experience, and we're not, we receive no incentive by saying Yuasa versus somebody else. Same thing with these strikes or any of the other product that we've shown you today. But I just love these different types of tools. And again, it's what I've found to be very powerful and been very successful in using. So Yuasa batteries are typically, again, rated higher. They're just slightly more expensive. They're not substantially more expensive. But the benefit is they're longer lasting and they're substantially stronger than most other batteries that are out there. So when you look at battery backup, again, the one thing that you want to look at is your inrush and your continuous duty of your locking hardware, as well as all of the other hardware that you have. So let's list a couple of things that you have at the door. You've got the panel, and it may be an edge device or it may be home run, but regardless, you have your panel, your lock, your reader, maybe a request to exit device. You've got all of these devices at a door, and then you've got your door position sensor. Door position sensor pulls no amperage, so that's not a device that you have to worry about. Your request to exit device, that pulls amperage, so that has to be taken into account when you're looking at your overall draw and how much battery backup you want to provide, okay? Your strike, same thing. Your mag lock. Now the difference in a strike and a mag lock are what we consider fail-safe and fail-secure, okay? A mag lock inherently is considered fail-safe. In other words, I need to provide power to it consistently, and if that power gets cut, those doors are safe to get out of, also safe to come into. They just stop working, right? It unlocks that door. Now with a strike, if you've got a fail-secure strike, that means that you're using power to unlock the strike, but inherently that strike is locked up. So when it's just sitting at idle, there's no power going to the strike at all. So I'll take that into calculation in the size of power supply that I use, but I also take it into calculation in the amount of battery backup that I'm providing, okay? But you can also switch most strikes or purchase strikes that are in fail-safe mode, okay? So if I've got a strike that's in fail-safe mode, now I need to provide continuous power to it, which increases the amount of power that I'm drawing continuously and is going to pull more power from a battery in a battery backup scenario. So you may have a 1.2 amp hour battery, right, that you see here, and a 1.2 amp hour battery may provide you 6 to 8 hours in a fail-secure scenario with a strike. But if you have it in a fail-safe scenario where you're continuously powering that strike, or you're using a mag lock, you could decrease that all the way down to a half an hour, depending on the size of the mag lock. So again, the way that you calculate that is by every data sheet that comes with every piece of hardware that you have. Pull your data sheet for your strike, for your mag lock, for your reader, and for your access control panel. Look at every single one of those, pull all of the amperage, and look at all the voltage, make sure that you're utilizing the right voltage, but then pull all the amperage so that you know I need to have a total of a half an amp provided for continuous duty at this door. Now, where your inrush and continuous duty play a substantial part is, let's say you've got a 2 amp power supply and you've got an amp and a half of continuous power being pulled, which isn't super typical for access control, depending on the locking hardware. But in this instance, you have to look at your inrush power. Because again, when that strike unlocks or locks back up, depending on the type of scenario you've got, if you've got a mag lock, your inrush is going to be when it locks back up. If it's on a strike, it's going to be when it unlocks because it's immediately drawing power, okay? So as you saw in the technical documents that I showed you, that your inrush can be substantially higher. So typically when I do calculations for battery backup, I typically always do those calculations based on inrush, but you can obviously look at the amount of devices that you've got in a building and you can get creative. So if I've got 20 mag locks through a building, I'm a huge strike guy, but for this instance, if I've got 20 mag locks in a building and I'm looking at the inrush, my inrush is going to be higher, but the likelihood of all of those mag locks being used at the same time with inrush is pretty low. So if my continuous duty is 5 amps of power, but my inrush is going to be a total of 6 or 8 or 10 amps or whatever it may be, I may just get a 6 amp power supply because I'm not going to have inrush on all of those at the same time. But again, be safe rather than sorry. So I know a couple of integrators that just throw a 10 amp power supply for every 8 doors that they do. They've taken an average of the amount of power that they're drawing, and they typically overpower because again, your hardware, or over amp I should say, your hardware is only going to pull the amperage that it needs. It's not going to, you're not going to have a 10 amp power supply and it's just shoving 10 amps to your hardware. So if you've got a piece of hardware that only takes 1 amp at 12 volts DC, you could have a power supply that's running 13.5, 14 volts, and you could be okay depending on, make sure you look at their literature, but you're going to be okay with power. But again, it's only going to pull a 0.5 amp from that power supply. It's not shoving 10 amps to that power supply out of the gate. So again, look at that. It plays a huge part into your battery backup. So now I want to show you this slide that goes, batteries ran in parallel versus in series, and this plays a huge part into 12 and 24 volt DC. Now obviously if I'm running 12 volt DC and my power supply is 12 volt DC and I'm running a 5 amp hour battery and I run one battery and I'm pulling 5 amps of power, I'm going to get roughly 1 hour, just shy of an hour. Now batteries have a burn-in cycle as well, so you're going to see eventually it's going to sag. It's not going to affect your hardware, but it's going to affect your total amount of battery backup time that you have. So when you're running a 5 amp hour battery, you may commit to your customer, hey, we're going to give you 1 hour of battery backup, and you put a 5 amp hour battery and you're pulling 5 amps of continuous duty. Number one, you're going to decrease that based on your inrush, so every time that unlocks and locks up, but also you're going to decrease it because that battery, over the life of the battery, will start to decrease, and you can get down to 50, 25, and then eventually 0% functionality there. So Ultronics has made some great battery monitoring built into their switching power supplies. In our door controllers, we've got some power monitoring in there as well, which is great. But also, again, make sure that when you run to 24 volts DC, you have to now run those in series. So again, coming back to the illustration, if you look at running these in series, you're going to see two 12 volt DC power supply or batteries. Now running them in series doubles your voltage, but it cuts your amperage in half. So if I've got two 5 amp hour batteries, typically if I was running at 12 volt DC in parallel, I'm going to get 12 volt DC output at 5 amps, or sorry, at 10 amps because I've doubled them up. If I'm running it in series, because I'm running 12 volts DC, I cut my amp hours in half that I can provide for battery backup, but I double my voltage, creating a 24 volt DC battery backup for a 24 volt DC power supply. So again, this is the substantial difference between 12 and 24 volt DC as well. When you look at long-term cost of ownership, in a 12 volt DC environment, I can just provide one 12 volt DC battery that's substantially larger. So what I want to do is show you a couple of the different types of batteries here. So if you look at these different batteries, I've got a 7 amp hour, an 8 amp hour in this different brand, a 1.5 amp hour, and a 5 amp hour battery. So if I'm pulling 10 amps of power, okay, for my hardware, and I put in a 5 amp power supply, or a 5 amp hour battery, I'm now decreasing my amount of battery backup by half, okay? So again, make sure that you're looking at those calculations, and if you look at the battery calculator here, you can see the hours of battery backup that I need, and it's a little harder to see on here, but if I say, okay, I want 2 hours of battery backup because they have a generator, or maybe I only need 1 hour of battery backup because they have a generator, then this tells me how many amps am I pulling and what is the size of amp hour of battery that I need. Now, if you put a bigger amp hour battery in there, it doesn't matter. You're going to get larger, or you're going to get a longer term out of your battery backup. So that's not an issue. Okay, I know we're out of time here, so what I want to do is just jump to the last slide here real quick. Hopefully the battery segment has made sense to you, but if you have any questions, there are many different types of calculators and such that are online. Like I said, we have these calculators here, which are nice, and we're happy to send one to you. You can get them directly from ASSA ABLOY, and they'll be happy to send them to you. But we've got a lot of upcoming courses. I sure appreciate your time today, and I hope this was valuable. If there were even a couple of small things that you found from this, make sure that you join our other courses. Again, these are provided to you at no cost. It's something that we wanted to do for you, maybe as a new installer or somebody that's new to the industry, or as you hire new installers if you're a business owner, to really help you guys have an edge when you go out there and install. Also, the greatest call that we receive into our support department is power related. So if we can also help decrease that amount of calls, it helps us decrease the cost of our hardware, which is something that's important to us. We've got 4 segments on sales and 4 segments on technical. So our next training is Why Customers Say No, which is April 28th at 10 a.m. And then we've got a great reader technology course that's happening on the 29th, going over standard Wiegand, OSDP, Bluetooth, all of the different types of reader technology. And hopefully what you've seen today is that we keep it very generic. This is not for us to pitch PDK to you. Hopefully you keep us in the back of your mind, but ultimately to help you have the tools that you need to be very successful out there. Now what I want to do is go ahead and turn over to the Q&A. So I'm going to end this here and see what questions you have. So the first question that we have here is from Mark. It says, when you have a power sag, would your strike take longer to release? That's a fantastic question. The answer is it's very possible that it could, and I have seen some of that, especially on a maglock, right? If you've got a maglock that, and it would be locking up, it would take longer to lock up. So you would kind of hear this click if you had a power sag. But again, that can damage a maglock and a strike just as easy as it can some of your other hardware. So make sure that you keep that in mind. But yes, it's possible. But again, not knowing the scenario or the type of strike and the power that it's handling, I couldn't tell you that for sure. Let's see. Hendra's got a question. Is it better to understand voltage over voltage for a camera system? What is the acceptance over voltage for a camera? And again, what you're going to look at is you're going to look at a camera's data sheet, and it's going to tell you what its over or under voltage is. Okay, so if I were to pull up this strike, it's telling me right here that it can handle anywhere from 12 to 24 volts DC. And it's not telling me that actually, let's see. It does not give me a specific range, but I know that a strike like this, you could run at 14 volts and you would be okay. So if you need to, and certainly on a camera, cameras have a lot of smarts inside of them. Runs very similar to a computer depending on the type of camera that you're using. And many of them are PoE, so they're going to be pretty standard. And we didn't get into PoE switches, which I wish we would have had time to. But again, look at the data sheets, call the manufacturer, look at what your top end voltage is, your lower end voltage, and just make sure that you stay within there and you'll be okay. Josh said, When you say longer distances and home runs are better for 24 volt DC, what sort of distances are you thinking of? So, again, 20, 30, 50 foot, even under 100 feet, I wouldn't consider many of those long distances. When you get in the 2, 3, 400 plus feet, those are going to be longer distances. But again, if you utilize a calculator like this, it really helps you understand, based on the distance that you need to run, what gauge of wire, and then again, understanding what your line loss is going to be at the end. If you go to that Ultronics calculator, it will tell you what your line loss is going to be at the end of that line, based on the gauge of wire that you're running. So again, it depends on the scenario, but typically if you're running 20, 30, 50 feet, I wouldn't consider those long runs. At what sort of distance does it begin to make sense to go with 24 volt DC versus 12 volt? I would, when I get into 300-400 foot wire runs, maybe even 200, depending on the gauge of wire, I would certainly consider running 24 volt DC, or putting the power supply closer to the hardware if you need to. And if you're running edge devices, then you're going to be doing that anyway. So let's see. Thera asked a question. What is considered substantial distance, which we just answered there as well. So it looks like that's the last of the questions. Are there any other questions that you have? Go ahead and type them into the chat, and we'll be happy to answer those for you. Doesn't look like we have any additional questions. If you've got more questions, please just chat those in. If you go to our website and go to the chat section, or you email support@ProdataKey.com, we would love to answer any questions that you have around power, running power, these distances. We can help you do some of those calculations. Happy to do so. We'll use some of the online calculators, as well as the calculators that we have available to help you determine if you should run 12 or 24 volt DC. Our sales team would be happy to help you with that as well, and they'll get with our tech team. So if you're running into any of these scenarios, make sure and reach out to us. This was really geared towards access control, but we want to make sure that you understand that this is low voltage in general. As you're powering and utilizing this type of knowledge for other technologies, most of it is very, very similar, especially when you're talking about powering it, battery backup, etc. And one of the things that, again, we didn't talk about were PoE and running PoE for different types of devices. So it's something that we'd be happy to answer on a one-off. But I will tell you, one of the greatest mistakes that's made in the industry is going out and buying a PoE switch and then and realizing that it's a PoE plus switch. Okay, so for those of you that don't know, a standard PoE switch typically runs at about 15 watts, maybe a little more. And a PoE plus switch typically is running 30 watts, and it's going to give you roughly 2 amps of power at your controller if you're using it for door control. So we clout with our door controllers, if you're running at PoE plus, you're going to get about 1.5 amps of available power for your hardware after you take the power that's used for the door controller itself. Okay. Well, the biggest issue that people run into is they buy a PoE switch, and this is just a small, inexpensive one. Typically, you're looking at much more expensive PoE plus switches. But if you're looking at this switch here, this switch is rated for, it actually doesn't have the rating on it. But let's say a switch that's a PoE plus switch, it's rated at 30 watts per port, but the max wattage that switch can handle is 90 watts. What typically happens is they'll go plug 3 devices in that are pulling a full 30 watts per port, and now all of a sudden they try to plug in the 4th, the 5th, the 6th, the 7th. Well, they've already used the total allocated wattage for that particular PoE switch. Now, if you're only pulling 15 watts per port, now you can double the amount of ports that you can use. So I can typically now plug 4 devices in at 15 watts per device on a PoE plus switch, because I've got 90 watts of total available wattage. So this is super important when you're looking at PoE plus switches. Make sure that you look at the total allocated wattage for that switch. Even though it's giving you 30 watts per port, you may only have 100, 200 watts for the entire switch itself. So if you're going to go power 10 doors off of it, you could really run into some issues there. And it starts to become very expensive. Now, it runs very similar to a standard power supply. The more expensive switch typically is going to have a higher wattage, overall wattage, and allow you to plug into each one of those ports and utilize it for more devices. A less expensive switch is typically going to have less ability and less wattage. We did get a quick question from Alex here. Is it possible to configure the O output terminal like on the cloud node? The answer is yes. So if you're using another door controller, and we won't really get into much PDK stuff here, but we've got an O output on our door controller. It's essentially a separate relay, and you can configure that, and you can run power next to it as well. So reach out to our support, and we'll help really understand what your scenario is there, and we'd be happy to help you understand how to configure that port. Again, thank you so much. We hope you found value out of this, and we hope you see value in the other courses that we've got coming down the line. Have a fantastic week. Have a fantastic month, and we really wish you all the health and success, and pray that your families and everybody are safe that are with you. Take care.